At this point, I'd like, gives me great pleasure to introduce our next speaker, Dr. Linda McCauley, who is Dean of School of Nursing at Emory University and has a research project, a PI, with the Southeastern Coastal Center. Welcome.
Thank you. Good morning, everyone. I'm delighted to be here and to share this work we've been doing for 4 years. I want to point out that Tom Bernard played a very critical role probably about 6 years ago, Tom, when we were developing the pilot work that would give us the initial data to write this R01 that was awarded. And Joan Flock, who's here, has been very involved because the project I'm going to be describing to you is embedded in the community and has been done in partnership with the Farmworker Association of Florida. And I think it's just amazing when you listen to Tom's presentation and hear this, you can really understand why this type of meeting is important as you work with very solid laboratory models, and then you go out in the real world and see what's going on. This was funded by NIOSH. It was a 4-year R01. The project ended in August. Our last data collection was in June of this year. So we're rapidly trying to complete as much data analysis as we can. But in this 4-year study, by the end of the second year, we were already beginning to see patterns emerging from the work. So we've had a number of papers published. Quite simply, we didn't have to get our full study sample to actually be able to document what was happening to many of the workers in the field. So what's amazing to me, and these are 3 case studies. The one on the right is a pregnant farm worker who died out in California. It was 95 degrees that day. She was working in a vineyard. No one knew that she was pregnant. She was a teenager. And then these 2 deaths on the left-hand side. One was in South Georgia in Moultrie, a farm worker who'd been working, 24 years old, been working every day, and then for whatever reason on that day, he collapses and he dies. And the same thing with the report from Naples with a farm worker who died on a bus on the way back from McCauley's. And so these factors that on a given day, it may not be the hottest day that worker's experiencing, but for whatever reason, it's the day that they go over the limit and die. So the framework that we've used to guide this work looks at 3 different areas. One is the actual heat hazard, what we know about safe levels of heat that workers can be exposed to. And then in the middle of this model are all these vulnerability factors, some of which are modifiable, like the clothing that a person wears and how much beverage they drink and what type of beverage. Some of them are not modifiable, like one's age and gender. But the heat hazard and the vulnerability lead to that that physiological response, the heat stress response. And we've included a number of things in the heat response, including symptoms, and I'll show you that. I've got some core body temperatures to show you, and also some information about the different types of work and what happens in the physiological status. So we published this framework in 2017, and I believe strongly in frameworks in terms of driving your hypothesis and how you examine how things interact, and I want to show you some of that. But these were the 5 communities in Florida that we were in. We started out in Pearson, and then Apopka, then Fellsmere, McCauley's, and Homestead. And what this did is give us a variety of different types of agricultural work, from ferneries to nurseries to crops. And all of this data was collected anywhere between May, June, July, August, the hottest time of the year, though we do have a sub-study of studying some of the same workers when the weather was cooler, that I won't be presenting those data today. And of course, you've already heard this, these recommended body temperature limits. We used the 38 degrees centigrade and the 38.5. We assumed that, well, we really didn't know whether, we assumed they were acclimated, but we knew our workers were not medically cleared because many of them are not seen by physicians. And the 38.5 is the level for people that are monitored, and we know they're not monitored other than being in our study. So I'm going to show you data on both of those limits. So what we did in partnership with the Farmworker Association is we recruited workers from a variety of different areas, and they agreed to wear this equipment for us, which included a heart rate monitor, an actigraph monitor, an eye button, which was given to us by the Florida Department of Health so that we could actually get real-time temperatures in their work environment. And then they swallowed a capsule that was a sensor for their core body temperature, and they wore a sensor around their waist also. And all of this equipment was worn under their daily work clothes. We also did biological samples for urine and blood osmolarity, and did surveys on symptoms and demographics. Just more about the equipment that they wore. This was not a detriment for enrollment. Our participation rate was over 65%. Only 1 or 2 workers refused to participate because of swallowing the capsule. So heat stress, how hot was it on the days that we monitored? So we used the fawn data that's generated in the Florida Automated Weather Network. And the mean heat index for the days that we monitored, the workers in this 4-year period, was 90 degrees Fahrenheit with a standard deviation of 6 degrees. The eye button data, you can see it's much hotter in the work zone. This was the eye button monitor that they wore on their waist. They also wore one on their neck. We didn't know the best place to put it, so we put 2 on them, and we were more satisfied with the waist measurement than the neck measurement. So this paper on comparing the phone data to what we found in the eye button data is in press in the Journal of Occupational and Environmental Medicine, where we're really looking at the utility of using our safety bands for temperatures that are generated from the phone data, and if they're close enough to what we see in the close work environment of the worker. So the vulnerability factors. This is our study participants, 38 years, and we're finding that 38 years old is 37. That's about the age in multiple states now of the ag worker population. Because of the decrease in immigration, we're not getting a huge influx unless they're H-2A workers. They'll tend to be younger, but this is an aging population, which I think is important in terms of heat stress. 62% of our population were women, working in ag for 12 years, from different countries, and I've already mentioned they worked in different types of crops. So I'm going to show you first the accelerometer data. Because agricultural work, the actual movement of the body, which contributes to the generation of a higher core body temperature, varies greatly. And so this is one of the first measures that we looked at, and the thing that we were most interested in is the last bullet, which was the time spent in moderate to vigorous activity. And so this slide is busy, but I think what you can see, look at the agricultural work type and look at the last line of the data where the moderate, vigorous activity. The workers in the fernery had 231 minutes in this active and vigorous activity compared to only 29 minutes for nursery workers and 121 minutes for persons harvesting crops. Here, this shows it a little clearer, and you can see the difference in the male and female. So the first two bars are ferneries, where you can see 61% of the males were engaged in moderate to vigorous activity compared to 71% of the females. We think this is the first report that will be coming out in terms of the physiological difference of males and females, and a lot of I think we have a lot of probably false assumptions that women don't work as hard, aren't as vigorous, and I think this kind of debunks that they're pretty comparable levels of moderate physical activity in the males and females. But the type of work that they're doing drives the difference. So these monitors, what's really funny about this study is that when we wrote this grant and we got it funded, we did not have a biostatistician on this grant. And then this wave of data hit us with all this real-time monitoring. Well, we were really scrambling in terms of how we were going to analyze this data, because these monitors will give you a reading every 15 seconds over an 8-hour work period, and there's a lot of noise in that data. There's a lot of data cleaning that you have to do, but you can see the difference in the patterns. So this, again, are the top curve, are the mean activity patterns for fernery workers over the work hours are at the bottom, from working when they started in the morning to up to 10 hours. And the middle line are the field crops, and the bottom line are the nursery. And quite frankly, nursery workers were more likely to be able to take breaks in air-conditioned areas, or at least areas with fans. So I think these data on activity validate what we already sensed might be going on in the workplace. One of the things I think that's also interesting, if you look at the ferneries, is they are not in direct heat. So I watched your slide, Tom, in interest in terms of the effect of direct heat exposure. They, of course, are in shaded or canopied areas when they're harvesting ferns. Hydration status. We've already had some questions about that today. So we collected urine samples before work. They would come to the Florida Farmworker Association offices in the morning before they went out in the field, and we would get a pre-shift urine and some other measurements and put the equipment on them. And for those of you who aren't familiar with specific gravity, pure water is a 1.0. Clinically, we look at 1.02 is the stage in which a person is considered dehydrated, and then 1.03 is the clinical indicator for severe dehydration. So these plots show the urine-specific gravity measures for the 248 workers over 549 days. So I didn't tell you that to begin with, but when we recruited the workers, we wanted 3 consecutive days of monitoring, which I think what was mentioned earlier about repeated exposures and whether what happens on one day predicts what happens on day 2. I think we were thinking along that same line. Not all of our workers gave us 3 days. That's why the numbers are a little bit different, but you can see that this is the AM and the PM plots. They're not more dehydrated on day 3. They look pretty similar, day 1, day 2, day 3. And consistently, their dehydration level is higher in the afternoon than it was in the morning when they came to work. And this is kind of interesting because I had one nephrologist tell me that they would expect to see dehydration in the morning because a lot of people don't get up and drink during the night, and it's not unusual to be more dehydrated in the morning. And so among our workers, 53% of them were dehydrated before work, but that grew to 81% after work. And then for the higher level, the clinical dehydration, 3% showed up already clinically dehydrated, and that grew to 13% at the end of shift. The reasons that they don't drink enough water or other beverages while they're working are complex. It's very difficult to get to those individual behaviors in the workplace and observe it. But anyway, we published this in the Journal of Occupational and Environmental Medicine, which basically was the hydration status and the kidney function. And I'm going to show you some slides on the kidney function because the kidney function was not part of our original conceptual framework. That's come up later, and I'll spend a little bit on that. So, how does the dehydration and the work activity predict the physiological stress? So here are the symptoms. 85, almost 85% of the workers reported at least one symptom. And the most common symptom was excessive sweating, which you would expect, but 18.6% reported at least 3 or more of these symptoms. This shows kind of the most prevalent to the least prevalent symptom, sweating, headache, dizziness, nausea, vomiting, muscle cramps, confusion, and 5% reported fainting over the period in which they were monitored. So we published how these patterns of symptoms last year also, and we are preparing a second paper with the final sample on these patterns of symptoms. Okay, so in this physiological response, this is an example of the monitoring for one worker. These recordings were every 30 seconds. If they had 2 consecutive readings of 38 degrees or 38.5 degrees, that we consider that over the physiological recommended limit or threshold. And like I said, there's a lot of data cleaning you have to do that with this. So we removed, the temperature and heart rate file was removed if greater than 20% of the data points were missing. But what's amazing is that you can really see the correlation of the heart rate and what's happening to the core body temperature. This is a great example. Not all the individual patterns looked as clear as this one, but in general, these are highly correlated. But The statistician that we did bring in, Vicki Hertzberg, right away wrote this paper kind of talking about how you clean up this constant physiological monitoring data and discern patterns for analyzing this real-time data. But the core body temperatures, 82% of the workers reached 38 degrees during their workday. 24% of them were at 38.5. Their heart rate, which is part of the physiological response, this shows that 20% had a heart rate, mean heart rate exceeding 115 beats per minute. That's for the whole entire workday. I haven't seen the data yet on how this heart rate varies by the type of crop, but I think what we have seen is that the accelerometer data, the activity data, and the heart rate are tightly correlated. So I would expect this heart rate to be highest in the fernery workers, but I can't verify that. So what we're in the midst of is our multivariate modeling of trying to look at these vulnerability factors and see what best predicts the heat response. And we're looking at, of course, the hydration status, the work intensity, gender, age, the body mass index, any medical conditions, breaks and shade. Because that's what our recommendations say, or breaks and shades. It's really hard to quantitatively measure that. But here's some of the initial modeling data. So you can see this is for the odds of having a core temp greater than 38. And you can see the models in which we put work intensity. You can see that the work intensity plays a role. The BMI is predictive, and the mean heat index, so that environmental temperature is predicting is actually every 5 degrees in the mean heat index increases the odds of a temperature over 38. And then a model where we considered dehydration. We had a hard time getting work intensity and dehydration in the same model, so you can see what specific gravity does. But heat indexes in both of these, and the BMIs in both of the models. This is the model for the higher core temperature of 38.5, and again you see the activity of their work. Here, for the first time, we're seeing years working in agriculture having a protective effect, which is an interesting finding. BMI, heat index, and in this we saw that males were much more likely to be at risk for the 38.5% temperature. But in this model, dehydration was not significant. So my time's up. I just want to tell you that at the same time we started doing this study, I'm going to go through these really quickly because at the same time we did this study, data was emerging about the possibility of heat exposure impacting kidney function. And so because we were getting biological samples, we were able to add this on. And so we have been studying kidney function. In Central America, it's chronic renal disease. In the United States, people are looking at acute kidney injuries. So we do have this data. We do have indications 32% had stage 1 of acute kidney injury. 3% had stage 2 of acute kidney injury. This is part of that paper that was published in the Journal of Occupational and Environmental Medicine because of the national attention to this problem right now. And the other things that we're looking at are trying to predict the heat stress symptoms and the core body temperatures and look at correlations between them, because in the real world, those symptoms kind of drive. That's where you can do emergency response and when you need to get in and intervene. Overall health status and work behaviors, we're not finished with that analysis yet. More work on the work intensity and the heat stress response, and then seasonal differences. I told you that we did data collection in the cool months versus the hot months. And then most importantly is taking all of these findings, translating them into Spanish or Creole, and getting this back out to the community. So there's a lot of intense work still being done on that. And then thinking about pilot interventions, that's our next phase, of course. What can we do to bring down these core body temperatures? We've been funded by the Southeast Ag Center to start looking at metabolomics in these workers. So we have some interesting data we're analyzing right now on what happens with the metabolomic profile when workers are exposed to heat, and then heat exposure in the microbiome. So here's a big team, lots of people working, not impossible to have done this without the Farmworker Association of Florida and the Ag Center and the support that they're giving us. So thank you very much.
And we do have time for a few questions if anyone has.
CDKs, are these folks?
CDKs.
CDK, have rapid myelitis?
No.
You saw it yourself?
Yes. We can probably get it in our metabolomics, don't you think?
Not necessarily.
But no, we did not run that. That was not one of the,
Activity levels.
right.
And obviously, elevated, rapid myelitis, muscle breakdown can cause kidney injury.
So we are doing that. A very small, it's one of the biomarkers that we're putting in in the Florida study. So we will have some biomarker data on that. The hypothesis that's really, we've been looking at it in terms of the kidney damage, that the muscle breakdown from this vigorous work might be driving some of the acute kidney injury that we're seeing. Is that what you're kind of thinking?
The easiest way to measure it is simply with CPK,
Okay.
which is, we do it routinely in medicine
Okay.
as a measurement. So
Okay.
It's something that's easy to do. It's just
Okay.
something to think about.
Okay. Other question?
Yeah, thank you for, excuse me, for a very nice talk. I had a couple of comments. First, I was interested in the data, the actogram data of the women. You actually may be underestimating how hard women are working.
Really?
Because what you find with agriculture work, most occupational tasks, people self-pace. They self-publish around 40 to 45% VO2 max. So my guess is that if you did estimate a VO2 max, that you would find that they're working at actually a higher percentage or an equal percentage. And there are ways, there are emerging technologies using actograms, and at the same time, you can start getting this relative intensity. And I think Jim Hodgson from Canada just recently published a paper showing the use of actograms for that.
Okay, good, thanks.
The second is, and I have 3 comments. Okay. Second is that I was interested in your specific gravity, because for specific gravity to have a real meaning, you really have to, urine specific gravity, you really have to hold certain controls for so many hours.
Exactly.
And I understand the difficulty. But with your post-exercise, and this is going to roll into my last comment, is that we know that with exercise and heat, or exercise even without heat stress, that you get what's called compensatory vasoregulation. You move blood away from the gut and the kidneys. So as a result, your glomerular filtration rate will drop and your urine-specific gravity goes up. So I guess I would say that I'm not sure what those post-exercise specific gravity means. And then rolling into the last point, those estimated GFRs going down, I would argue that rather than acute kidney injury, they just might represent a normal physiological response to exercise or heat stress.
I think you're exactly right, and this whole issue of kidney damage from exposure to heat and this vigorous work is quite controversial, and there's many people that believe this is just normal physiological response, and it's not going to, it's just the way the body compensates, and it's not really indicative of kidney damage, so it is quite controversial. We did measure serum osmolarity for some of the same reasons you're talking about. Specific gravity does have limitations. It's also much easier to get urine from the workplace than it is to get blood. And so that is another analysis we're going to be doing, is comparing the patterns we're seeing with specific gravity to the serum osmolarity. So.
What are the predominant activities for farmworker workers that leads to such a higher prevalence of vigorous work versus crop workers? I'm just ignorant on the topic.
I think if you if you're in the workplace, you see it completely. First of all, they're working primarily by the piece, and so they're harvesting as fast as they can, and they're paid by the number of bunches that they do, but their work involves bending at the waist to clip the ferns at the base of the earth, and then taking those ferns, wrapping some type of cord to hold it together, and then tossing that fern. So that is, that is much more strenuous than bending over, not all the way to the ground to pick tomatoes, right? And what's amazing is you can see that difference. But I've not seen an agricultural work where there is as much bending at the waist, arm, waist, leg, walking up and down the rows doing this. I think it's a unique type of agricultural work, and it's something that the Farmworker Association of Florida centered in on right away about how strenuous that work is. Right, Joan?
And I also would bring up that as compared to the nurseries are, in fact, a fairly gendered workspace in that the male workers in nurseries probably do different tasks than women do. That's why you might see the difference in the male activity in nursery. They're going to be more involved in heavy lifting probably than the women are. Mm-hmm. But in the ferneries is pretty much non-gendered. Everybody's doing the same work. So.
Yeah.
Not to blab too much, but I think that's interesting. One of the early comments was one of your outcomes is going to be injury or
Mm-hmm.
accidents.
Mm-hmm.
And there's emerging literature, in fact, in the last few months, showing that heat stress, and then it's aggravated farther by dehydration, affecting coordination, these types of things. And so I think the idea is you start laying these things on, it really would be a fertile area to go with accidents and injuries, and then maybe mitigating that more than maybe just heat strain. But
That's right.
focusing on that.
Good point. So thank you very much.